In Unit 7, opener number 13, you are asked to work with function notation. This is one of the most important parts of working with functions and can often be confusing to students. Function notation is stated as f is a function of x and written as f of x. All this means is that for input x, there is a relationship for which that input creates only one output, known as f of x. It's tempting for a lot of students to read this as f times x and to think that this means multiplication, but it doesn't. You want to make sure that you read it as f of x. For example, f of 5 is the function value when 5 is entered as the input. The reason why this notation came about is that would be really a long process if every time we asked you for f of 5, we had to ask you for the function value when you're entering 5 as the input. F of 5 is just a much shorter way to ask you to substitute in 5 for the input and to find the output. Another example is when you're finding the value of x for which f of x is 5, you're creating the input to create an output of 5. So below we're going to do both of those things. Number 1 is asking you for f of 12. The f just points you in the direction of which function you're supposed to be looking at, and 12 points you in the direction of what input you need to be substituting in. So this means we want to be looking at the function that's named f, and we want our input to be 12. And what we're looking for is the output. So all we have to do is go to f, and in place of x, we need to substitute in 12 in its place. So what we have is the absolute value of 3 times 12 minus 7, which is the absolute value of 29, which just equals 29. Because f of x is a function, that means for each input there should be only one unique output. So when we substitute in 12 for x, as long as f of x is a function, we should only get one answer for our output. Sometimes when you're given the output and you're asked to solve for the input, you might get more than one solution, but whenever you're given the input, you should only get one unique output. Number 2 is asking us for g of 24. So g of 24 tells us to look at the function that's named g and to substitute in 24 for x for the input. So g of 24 equals the square root of 24 minus 9, which is the square root of 15. And since that's a messy number, I'm just going to leave it as square root of 15. Finally, h of negative 3 tells us to look at the function that's called h and to substitute negative 3 in for x. So what we have here is opposite of negative 3 plus 10. Well, the opposite of negative 3 is positive 3 plus 10 equals 13. Well, the next 3 parts ask us to do the reverse. This time we're given the output and we're being asked to substitute that in to find the input. So the first one says f of x equals 18. So that means that we're going to be looking at the function that's called f, and we're going to be substituting 18 in for f of x, or the output. So 18 equals the absolute value of 3x minus 7. Here is an example like what I was talking about earlier, where there's actually going to be 2 different possible inputs that could give us an output of 18. And that's okay. So the way that we could solve this is, since this is an absolute value equation, we could take the input of our absolute value equation, 3x minus 7, and set it equal to positive 18 or negative 18. And then we're going to end up with 2 solutions. So if I add 7 to both sides, I get 3x equals 25. Divide both sides by 3. I get x equals 25 thirds. Or I can add 7 to both sides. I get 3x equals negative 11. And when I divide both sides by 3, I get x equals negative 11 thirds. That means if I substitute 25 thirds in for x, I should get 18 as my output. And if I substitute in negative 11 thirds for x, I should also get 18 as my output. Number 5 is going to be pretty similar. I'm going to look at g of x, and it says that I want to find x if g of x equals 4. So that means I'm going to take 4 and substitute in for g of x, my output. And I'm going to be solving for x. Well, to undo a square root, I need to do its inverse operation and square both sides. And I end up with 16 equals x minus 9. So when I add 9 to both sides, I see that this time I actually only get one solution for a possible input that could work. 25 is the only x value that I could substitute in to get an output of 4. All right, the final example that looks like the last two that we just did is find x if h of x equals 19. So this tells us to go to the function that's called h, and to substitute in 19 for h of x, for the output. 19 equals the opposite of x plus 10. And this time again, we're only going to get one possible input that gives us an output of 19. I'm going to take away 10 from both sides, and I have 9 equals the opposite of x. So that means that negative 9 equals x. So in the first three examples, we were given an input and we had to solve for the output. In our second three examples, we were given an output and we had to solve for the input. Finally, in number 7, we're asked to do a bunch of different function operations. This is called sometimes the composition of functions. And you always want to work from the inside out. So this looks like a really complicated process, but really we're just going to be evaluating 3 different functions for 3 different inputs. So when we start on the inside, I see h of negative 3. So the first thing that I'm going to do is to find h of negative 3. So that means I need to go back to the top and look for the function that's called h and substitute in negative 3. I see that we actually already did that in problem number 3. We got 13. h of negative 3 equals 13. So now I'm working from the inside out. I've done h of negative 3 already. If I keep working my way out, now I see that I need to do g of that. So I need to do g of 13. So I'm going to go back to the top. I'm going to look for function g, and I'm going to substitute in 13 for x. So I need to do square root of 13 minus 9. Which is the square root of 4, which equals 2. And finally, when I go back to what I'm trying to do, my last step is to do f of that. So f of 2. I go back to the top, I look at my function that's called f, and I need to substitute in 2 for x. So I need to do the absolute value of 3 times 2 minus 7. Which is the absolute value of 6 minus 7, or the absolute value of negative 1, which equals 1. So f of g of h of negative 3 equals 1. So some basic advice that I have for working with function notation is remember that if something says f of 12, it doesn't mean f times 12. It means take 12 and substitute it in for the input of function f. If something asks you to find x if f of x equals 18, that means you're being given the output and you need to substitute that in to solve for the input. And finally, when you're dealing with a composition of functions, you just have to work from the inside out and keep peeling back the layers until you've evaluated the whole thing that you were asked to find.